Hello and welcome to the sixth and final video in our series on the cash in advance model. In this video, we're going to be talking about what the optimal inflation rate is inside this model. And to do that, we're going to go back to a concept that you saw last semester, and that is the planner's problem. So the idea here is how to figure out the optimal monetary rule. Well, we can look at the planner's problem, because the planner is this fictional character that can choose the optimal allocation of the economy, the allocation that maximizes the welfare of agents, that maximizes the utility, being subject only to the feasibility conditions, so to the technological constraints of the economy. The planner doesn't have to care about prices or assets, and in particular, it doesn't have to care about the cash in advance constraint that the consumer is facing. So the planner is just free to move consumption and labor in a way that will make the consumer as happy as possible. It's going to maximize that utility, taking only into account the fact that it has to be feasible. And so how does the problem looks like? Well, the problem is what's the highest feasible value of utility. So the objective function is the same as for the agent. This is the same as in the consumer's problem. But instead of being subject to the budget and the cash in advance constraint, the planner is only subject to the feasibility constraint, the fact that consumption cannot be higher than output. You could solve these with a Lagrangian, but it's actually much simpler in this case to just replace the constraint into the objective function. That is this last problem we have here. So instead of solving for both consumption and labor, we're going to solve only for labor, knowing that consumption is always going to be equal to total output. So this is going to give us the objective function of the planner. And in order to characterize the solution to the planner's problem, we only need to take the derivative of this problem with respect to labor for every period. And we can see that here. So the optimal allocation is characterized by the first order condition of the planner. And the first order condition of the planner, it's equating the marginal cost to the consumer of working an additional hour with the marginal benefit. In that hour, the consumer is producing ZT units more, and it's consuming them, which is going to give it a marginal utility value here. So this is how the planner is weighting the different options of how much to work. If you compare that with what happens in the full model, there is a difference here by beta over 1 plus alpha. If you remember that beta over 1 plus alpha, it's going to be related, of course, to the nominal interest rate. Now, you can notice that if beta over 1 plus alpha happen to be equal to 1, then both conditions will be the same. If the conditions are the same, then the sequence of consumption and labor that the model will give you will be the same sequence of consumption and labor that the planner will have chosen. So the same consumption and labor that will maximize utility. Those are the optimal consumption and labor. And so what we want is that this equality holds. So let's look at it. For this equality to hold, we're going to need that 1 plus alpha, it's exactly equal to beta. But beta is less than 1. So this is implying that alpha, which is going to be equal to beta minus 1, has to be negative. So it is optimal to have the money supply decrease at a constant rate of beta minus 1. And why is that? Well, let's go back and think about the return on money. If you remember from our previous module, the return on money is 1 over 1 plus I. But we know that in steady state, that is 1 over 1 plus alpha. And now we know that this 1 plus alpha better be equal to beta. So this is 1 over beta. But that we found is the real interest rate. Now what's interesting about this is that when money is going down at this rate beta, this equality tells us that the agent is going to be indifferent between holding money or holding any real asset, because the rate of return on money it's going to be equal to the rate of return on any real asset, and by non-arbitrage, to any asset. Now, when the agent is indifferent between saving in absolutely all assets, then the cash in advance constraint no longer binds. In fact, you can show, and I leave this as an exercise, that the multiplier on the cash in advance constraint is then equal to 0. So the cash in advance constraint no longer binds once the agent is indifferent between holding money or holding any real asset. This result, which is very important and very surprising, was first derived by Milton Friedman, and so we call this the Friedman Rule. The fact that the money supply should decrease at a rate so that the return on money is equal to the real interest rate. Now, this is not to say that in real life alpha should be negative and we should be declining the money supply all along. This is a steady state solution. We are not in steady state, and there are a large number of shocks that affect us in the short run that we're not taking into account in this model. Another thing we're not taking into account is the fact that prices might be fixed or sticky in the short run. So we also don't have that. So do not take these as a literal prescription of what the money supply should do, but it is still very instructive to think that in fact inflation is distorting the behavior of agents. And the way to make inflation not distort that behavior is by equating the return of money to the return to other assets. With that, we've finished this module. And so the overarching lesson is that even if money is neutral, inflation, that is money growth, is going to have real effects. And part of those real effects come from the fact that inflation, money growth, is going to be distortionary in the decisions of agents of which assets to hold and how much to work. That is all.